Given that sine theta is equal to root 3 over 2, express in fractional or third form cosine theta. Now, let's look at part A. Sine theta is equal to root 3 over 2. So we know that sine theta is equal to the opposite side of a right angle triangle divided by the hypotenuse of that right angle triangle. And since we're given that the sine of theta is actually equal to root 3 over 2, it is saying to us that the opposite length is equal to root 3. And it's also telling us that the hypotenuse is 2. So what we need is the adjacent length. We need the adjacent length because, you know, a right angle triangle has 3 sides, obviously. Every triangle has 3 sides. Now, let's just design a right angle triangle, and let's call this acute angle here theta. And so opposite theta is going to be root 3 because we're told that the opposite side is root 3, and the hypotenuse facing the 90-degree angle is the measure of 2, the side with length unit 2, right? And we're trying to find the adjacent side. That's the side with the right angle and the acute angle, the side that's next to the acute angle. So now, because it's a right angle triangle, we need to use a Pythagorean theorem or Pythagoras theorem, which is c squared equals a squared plus b squared. And rearranging this, we can find the length of one of the shorter sides, that is a or b. And we can find that by the square root of c squared minus b squared. Okay, so what is c squared? C here is the hypotenuse, so we're going to square 2 and subtract the square of the other short side, which is root 3, square of root 3. And so this gives us 4. All right, so this will give us 3 here. We can say a is equal to 1, and so yeah, a is equal to 1. Now we can insert that because the a here represents the adjacent side that we're looking for, right? So we have the 3 sides now. So the adjacent side is actually 1. So now we can actually find the cosine of theta, which is the formula adjacent length over the hypotenuse. We know the adjacent length. We just found it. It's actually 1. And the hypotenuse is 2. So we have the result for that one, which is 1/2 or half. Same thing. Tan theta is equal to the opposite length divided by the adjacent length. And all this has to do with the right angle triangle. And the opposite length for this particular triangle is root 3. The adjacent length is 1. So that's simply root 3. So let's look at part 2. Now, sine theta divided by tan theta. So what is sine theta? Sine theta, as we have here, is root 3 divided by 2. Root 3 divided by 2. That's sine theta. Now I'm going to divide by tan theta. So I'm going to divide that by the tangent of theta. What's the tangent of theta? Root 3. So this part here is sine theta divided by what? Tan theta. So that's what we're asked to find, correct? So what I'm going to do next is to change division to multiplication. No, by the way, let me just put this over 1. So I'm going to change division to multiplication. So let's put back root 3 over 2. Now, because I changed division to multiplication, I must reciprocate or upturn root 3 over 1, which is 1 over root 3. Now I'm able to simplify. Since when you look at the product of 2 fractions, you simplify numerator with denominator using a highest common factor or just a factor. So root 3 can actually enter itself as well as itself again. So all we're left with is what? What are we left with? We are simply left with 1 over 2. And I'm sure you can see why. So this is the solution for sine theta over tan theta, 1/2. And we did find for tan theta, right? That was All right, that is root 3. So please subscribe. Don't forget to subscribe to this channel if you haven't done so. And you can also like the video as well. You can actually comment, and you can also share the video with someone who may benefit from the video.